research concerns making efficient and effective use of information to track and understand the energy efficiency of buildings and its energy systems. The reason why it's important is because buildings and the built environment more broadly is a significant contributor of carbon emissions, but at the same time, it's absolutely crucial to the quality of life. Hence, it becomes extremely important that we understand where and how energy is used in our buildings, and to be able to drive it towards zero carbon futures, and at the same time use that opportunity to improve the quality of life that buildings give us. As engineers, we traditionally rely on some kind of experiments or models to understand how our buildings and energy systems operate. We live in a society that is fortunately becoming quite data rich, and that gives us a huge opportunity because now we can begin to understand the operation of our environment to high degrees of realism, which puts us in a much better position to be able to act because we have the evidence to do so. The university by itself is also an estate comprising of hundreds of buildings. And it does give an opportunity for researchers like me to not just look at one building at a time, but to look at an estate as a whole. And there are huge opportunities there because what is often prohibitive with respect to decarbonization of buildings is not technological solutions, but it's often the capital cost. And we all know that. We all understand that it's very difficult for us to renovate buildings, to be able to take down energy systems that might be inefficient or put in insulation at the cost of space, etc. But if we zoom out and if we look at more than one building at a time, that opens the window of opportunities where we can potentially look at sharing of resources. We can also look at reducing waste by leveraging waste streams in one place that may be required in another place. Another area where this can be a huge benefit is increasing the utility of the system. So if we are sharing because a certain building needs heat at a different time than another building, that becomes an opportunity as well because you can share the same system, they're just using it at a different time. And that is what we are currently exploring across Cambridge as a whole, to understand if we can have heat networks that are at low temperature, powered by geothermal systems, or if we can understand which buildings are more flexible than the others. Another point that becomes very relevant here is that Cambridge doesn't exist in isolation. We are part of a wider ecosystem comprising of our colleges, but also the town itself with its residential population, with its other buildings that include healthcare, retail, offices, etc. And then also the transport network, presumably in the future, which is also going to be electrified. And looking at the system as a whole is important because that's the way we can bring down costs. That's the way we can ensure that we are working synergistically with one another rather than against one another. One aspect where we are working very closely with our estates is the electrification of heat. We are specifically looking into the potential of sharing geothermal systems across buildings and having low temperature ambient heat networks, but also bringing in heat storage into the mix and looking at hybrid solutions that can tide us in the medium term. It's important for us to look at the campus as a whole and opportunities for sharing resources. So if there's an open piece of land that can be shared across 3 or 4 buildings, that provides us the space needed to embed closed-loop boreholes for geothermal systems. So that's the level of analysis we are doing. But in doing so, what we also do is look at the ecosystem, because if you're continuously drawing resources from underground, you can have a long-term adverse impact. So it's very important for us to also track that we are using the resources sustainably. So what we do is we look at how much we need to extract from the ground, but at the same time we look at the long-term effects so that the ground doesn't freeze over, or that we are balancing the ground sustainably so that we are able to use it for longer periods. We are looking into optimized solutions where we can balance the availability of certain types of systems for heating, such as heat pumps, and how they are used efficiently at the point of demand. So one of the very successful partnerships we've had is with an underground farm in London, which is housed in former air raid shelters. This is 30 meters below ground. They're growing microgreens and selling them within the city across London. And this is a derelict space that was otherwise being waste. It also sits in a situation where it has stable temperatures around, and it uses heat that's generated from the nearby tube tunnels. So really, it's about managing and understanding the resource flows and energy use in this environment so that the plants can grow with sufficient yields for the business to be successful. And we've been doing that through the development of digital twinning, which is a technology that brings together data, models, as well as expert knowledge to be able to provide feedback. So we've developed a digital twin product for the farm where the farmers are able to check in every morning with respect to how to control the ventilation systems, their dehumidification, their temperature and lighting controls, and be able to manage farms effectively.